Hello viewers, in today's lecture we are going to take up some important problems related to tangents and normals. Now viewers, in my earlier videos I have discussed in detail regarding the concept of tangents and normals. Now here we will take some problems. So the first problem is find the slope of the tangent to the curve at the point on it whose x coordinate is 2. Now here suppose this is the curve and we have to find the slope of the tangent at this point. Say this point is P and whose x coordinate is 2, right? So this point may be 2 comma y1, right? Now we have to find the slope of this tangent, and this curve is given by this equation, that is y is equal to 3x square minus 6x. Clear? Now we know that slope of tangent is given by the derivative of y with respect to x, where y is given by this equation. Now we find the derivative of this function. So we have 3x d by dx of 3x square minus 6x. So here we have 6x and minus 6. Now we have to find the slope at x equal to 2. So the slope of tangent at x is equal to 2 is given by this derivative at x equal to 2, and here we will put the value of x. So this is 6 into 2 minus 6, that is 12 minus 6, that is 6. So this is the slope of the tangent. Now suppose we have to find the slope of normal. So what is the normal? Normal is a line which is perpendicular to this tangent at this point. Clear? So this is the normal and this is the tangent. So the slope of the normal is given by the reciprocal of negative of the reciprocal of the slope of the tangent at x equal to 2. So here we have minus, this is minus 1 divided by the value of this slope is 6, right? So therefore this is the slope of the normal. Now viewers, let us take this problem. Here we have to find the slope of the tangent to the curve y is equal to x minus 7 divided by x square minus 5x plus 6 at x equal to 1. Now we know that the slope of tangent is given by m is equal to dy over dx. So our main aim is to find the derivative. So viewers, always remember that in calculus the derivative plays an important role. So let us first find the derivative of this function. So here we will apply the quotient rule, that is x minus 7 divided by x square minus 5x plus 6. Now we have to find the derivative. Now here we will apply the quotient rule. So we have x square minus 5x plus 6 then derivative of x minus 7 is 1 minus x minus 7. Then we have derivative of this function, that is 2x minus 5, right? And in the denominator we have x square minus 5x plus 6 whole square. Now if we simplify this expression, we have x square minus 5x plus 6, and then we have minus 2x square plus 5x, and then we have 14x, and then we have minus 35. Clear? And here we have in the denominator x square minus 5x plus 6 whole square. Now minus 5x and 5x get cancelled, and x square minus 2x square is minus x square, and here we have plus 14x, and 6 minus 35 is minus 29. So this is divided by x square minus 5x plus 6 whole square. Now we have to find the slope of the tangent, and at x equal to 1, so here we will substitute x equal to 1. So therefore slope is dy over dx at x is equal to 1. So here we substitute minus 1 square plus 14 times of 1 minus 29 divided by 1 square minus 5 times 1 plus 6 whole square, right? So here we have minus 1, and here we have minus 1 plus 14 minus 29, this is divided by 1 minus 5 plus 6 whole square. Clear? Now if we simplify it, this is minus 30 plus 14, this is minus 16, and we have 6 plus 1 7 minus 5 2, 2 square is 4, so we have minus 4, right? So this is the slope of the tangent to this curve at x equal to 1. Now the slope of tangent, the slope of normal is equal to the negative of the reciprocal of the slope of tangent. So we have minus 1 divided by minus 4, that is equal to 1 over 4, right? Now viewers, here we have the problem: find the slope of the tangent and normal to the curve x equal to sine 3t, y is equal to cos 2t at t is equal to pi by 4. So here we are given the parametric equations, and here t is the parameter. Now the slope of tangent is given by dy over dx, right? Now dy by dx can be calculated in when we are given the parametric equations. We will have here dy by dt and dx over dt. Now dy by dt is minus 2 sine 2t, because the derivative of cos 2t is minus 2 sine 2t, and here we have 3 cos 3t, right? So at t is equal to pi by 4, the slope is minus 2 by 3 sine 2 pi by 4, because we will substitute the value of t. Here we have cos 3 pi by 4. Now this is minus 2 by 3, this is sine pi by 2, and this is cos 3 pi by 4. Now sine pi by 2 is 1, and cos 3 pi by 4 is 135 degrees, right? Cos 3 pi by 4, it is cos 135 degrees, which can be written as cos 90 plus 45. This is minus sine 45, and this is minus 1 over square root of 2. So here we have minus 1 over square root of 2. So minus and minus get cancelled. So we have 2 root 2 divided by 3, right? So this is the slope of the tangent. Now the slope of normal is equal to negative of the reciprocal of the slope of tangent. So here we have minus 1 divided by 2 root 2 by 3, and taking 3 to the numerator, we have minus 3 divided by 2 root 2. Clear? Now viewers, let us take this problem. Here we have to find the equation of the tangent to the curve at theta equal to pi by 4. Now we know that the equation of tangent is given by y minus y1 divided by x minus x1 is equal to the slope of the tangent, right? Here mt denotes the slope of the tangent, which is calculated by dy over dx. Now here we are given the parametric equations, so we'll find here dy over dx. So dy over dx is dy over d theta, and this is dx over d theta. Now dy over d theta is obtained from this expression. So we have 1 because the derivative of theta is 1, and minus sine theta, the derivative of sine theta is cos theta, and then dx over d theta we have sine theta. The derivative of 1 is 0. The derivative of cos theta is minus sine theta, so minus and minus plus. Now at theta equal to pi by 4, if we substitute here theta equal to pi by 4, we have sine pi by 4 here. So this is 1 minus 1 by root 2 divided by 1 over root 2, and this is square root of 2 minus 1 square root 2 multiplied square root 2 divided by 1. So we have square root of 2 minus 1. So this is the slope of the tangent. Now what is y1 and what is x1? So x1 is obtained from here. We have 1 minus cos pi by 4. This is 1 minus 1 by root 2. And what is y1? y1 is obtained from here. We have pi by 4, because here we will substitute the value of theta. So this is pi by 4 minus sine pi by 4. So here we have pi by 4 minus 1 over root 2. Now substituting all these values here, the required equation is y minus y1. y1 is pi by 4 minus 1 by root 2 divided by x minus x1. x1 is 1 minus 1 by root 2 equal to square root of 2 minus 1, right? So therefore if we simplify it, we get y minus pi by 4 and minus plus. So here we have 1 over square root of 2 divided by x minus 1 plus 1 over square root of 2 is equal to square root of 2 minus 1. So this is the required equation of the tangent. Clear? Now viewers, let us take this problem. Find the points on the curve y is equal to x cube at which the slope of the tangent, that is the slope which is dy over dx, the slope of the tangent is equal to the y coordinate of the point. So the y coordinate is, say, y1, right? So suppose this is the curve, and here we have the tangent. This is the tangent, and at this point suppose the coordinate is x1 y1, and this is the curve, right? So this is tangent, slope is dy by dx is equal to y coordinate of the point. So dy by dx, if we differentiate this function, we get 3x square, and at this point we have 3x1 square equal to y1, right? Because dy by dx is 3x square, and at this point P, dy by dx at point P is 3x1 square. Now y1, we have 3x1 square is equal to y1, so we can have 3x1 square is equal to here if we substitute x1 comma y1, we have x1 cube, because y1 is equal to x1 cube. Now if we solve this equation, we have 3 minus x1 times x1 square is equal to 0. Clear? Because we take x1 cube to this side, and then we have this equation. Now from here we get 3 minus x1 is 0, or x1 square is equal to 0. So from here we have x1 is 3, and from here we have x1 is 0. So if x1 is 0, so y1 is also 0. 0 cube equal to 0. And when x1 is 3, here we have y1 is equal to 3 cube, that is 27. So therefore the required points are 0, 0, 0, 0, and 3, 27. Now viewers, let us take this problem. Here we have to find the equation of tangent and normal to the curve at t equal to pi by 6. Here again we are given the parametric equations of the curve. Now the equation of tangent is given by y minus y1 over x minus x1 is equal to slope of the tangent, that is dy over dx. Now let us find dy over dx. So dy over dx is dy over dt divided by dx over dt. Now dy over dt is calculated from this. So we have minus of sine t, and dx over dt is 2 cos 2t, right? Now at t equal to pi by 6, we have here minus sine pi by 6, then we have 2 cos 2 pi by 6. This is sine pi by 6, that is 30. So this is minus 1 by half, and here we have 2 cos pi by 3, right? So this is minus half, this is minus half, and this is 2 times cos 60 degree, that is half. Clear? So half and half get cancelled, so we have minus 1 by 2. So this is the slope of the tangent at t equal to pi by 6. Now what is y1? Y1 is cos pi by 6, and this is cos 30, and cos 30 degree is root 3 by 2. And what is x1? X1 is sine 2 times of pi by 6, that is sine pi by 3, and this is sine 60 degrees, which is equal to again 3 by 2, right? So now we substitute these values here, we get y minus y1 is root 3 by 2, and here we have x minus root 3 by 2 is equal to minus half, right? So if we simplify it, we get 2y minus root 3 divided by 2x minus root 3 is equal to, because 2 and 2 get cancelled, and we have 2y minus root 3 divided by 2x minus root 3 is equal to minus half, right? Now if we simplify it, we have 4y minus 2 root 3 is equal to minus 2x plus root 3, right? So this is 4 minus 2 root 3, this is minus 2x plus root 3. Now if we simplify it, we get 2x plus 4y is equal to root 3 plus 2 root 3, that is 2x plus 4y is equal to 3 root 3. So this is the required equation of tangent. Clear? Now we want to find the equation of a normal. So what we will do, we will write, or we will make a small change in this equation. So equation of normal is y minus y1 divided by x minus x1. So here we have the slope of normal, which is equal to minus 1 over slope of the tangent, right? So here if we substitute the values, we have y minus y1 is root 3 by 2, and x1 is again root 3 by 2, and here we have minus 1, and the slope of the tangent we have just calculated, it is minus 1 over 2. So here we have minus 1 over 2, minus and minus get cancelled, so we have 2. This 2 will go to the numerator, right? Now if we simplify it, we have 2y minus root 3 divided by 2x minus root 3 is equal to 2. Now multiplying it by 2 here, we have 2 minus root 3, that is equal to 4x, 2 to the 4x minus 2 root 3. So we have 2y is equal to 4x minus 2 root 3 plus root 3. So here we have 2y equal to 4x minus root 3. So viewers, this is the equation of normal, right?